Hello everyone and good evening to all. I welcome you all to the platform of Infinity Learn People by Sri Chaitanya. Okay, and today we will be having a session on the score. As you people know that we are here to make you practice about the score people. Okay, so today we will be having all the questions related to the class 10th physics. Okay, and we will be practicing according to that. So let us begin with the particular session people. So what will be the So let us start with the session. Okay, why to waste the time? So this is going to be your first question, people. Okay, and I request you all to please let me know your answers for this. So let us say that you people are having 2 minutes of time. Okay, 2 minutes, people. Let me know your answers for this. It is a very simple question. It is a very simple question. An object is initially at a distance of 100 centimeter from a plane mirror. If the mirror approaches the object at a speed of 5 centimeter per second, then after 6 seconds, the distance between the object and its image will be what? So you have to find out that. Please let me know for this particular question. It is a very easy question, people. What do you think? To do this particular question, you don't require much, what do you say, information related to the mirrors and the image formation and all. Okay, there is only one point that you require. Okay, that as we all know, this question is all about the plane mirror. So the image, the distance between the object and the mirror will be the same as the distance between object and the image, everyone. Okay, so this will be the same. So you have to give the answer. We want the total distance from, not from the object to mirror, we want from the object to image. What will be the distance? Okay, so what will be the distances? Just a logical maths. It doesn't require any information regarding the mirror formula or something like that. Okay, it is just a simple logical maths. Can you please just think about it? A very simple question it is. Very simple question. What do you think? What do you think? The time's up, people. So let us solve this particular question. It is a very simple question. What you have to think is, see, for an example, let us suppose that this is the mirror. Okay, this is going to be the mirror and this is going to be the object. Okay, right now this is going to be the object. Okay, the distance from here to here is 100 centimeter. Simple understanding. So its image will be also 100 centimeter. Okay, its image will be also 100 centimeter, like this. This is also 100 centimeter. Now, what is happening is, as you can see over here, the plane mirror, this is a plane mirror, everyone, and we know what is the object distance will be equal to the image distance from the mirror. Okay, we know if the mirror approaches the object with the speed of 5 centimeter per second, means in 1 second, it is traveling 5 centimeter. Simple words. So that's why in 6 seconds it will be traveling 5 into 6. That is going to be 30 centimeter, everyone. Okay, 30 centimeter. That means the plane mirror will be shifting towards the object 30 centimeters more. Now the new place of the object will be like this, for an example. Okay, so the distance between this and this is going to be 30 centimeter. In short, the actual distance between object and the mirror, it is going to be 70 now. If it is 70, this image is also going to shift. How much it is going to shift? It is going to shift 30 more. It is going to shift 30 more. So it will be, the distance will be from here to here. So it is 70. It is 70 and the image will be also going to shift. Like for an example, it is also going to be shifting. Getting my point? So how much it is? It is also going to be 70. So 70 plus 70, it is going to be the distance distance between object and the image is 140 centimeter. The basic logical question it was. Okay, so that is 140 centimeter. That is option B. This type of question will be come in score examination. Yes, this type only. This time only. Vandana. Okay. Duration will be what? It will be according to the question. Hai na? Which grade you are, I believe. Fine. The same duration will be there. So this is one of the first question. Let us move to our second question, everyone. So you don't require, for solving this particular question, you don't require anything. Anything means you do not require the basic information of the means the calculation of the mirror formula or something like that. No. You just require a basic mathematical skill and one property of the plane mirror, that the distance between the plane mirror of the object will be equal to the distance between the image and the plane mirror. That's it. Okay, so let us move to our next question, which is this. Again, it is going to be a very simple question. Okay, again, it is going to be a very simple question. Again, I will just give you 2 minutes of time to solve this. Let me know your answers for this. Come on, people. It is again very simple question. What do you think about this? What do you think? What will be the answer for this, people? A convex mirror of a focal length f in air is immersed in the liquid where the refractive index is given as 4/3. The focal length of the mirror in the liquid will be what? Very simple question it is. Very simple question. Very simple question. So let us begin with the answer, everyone. Okay, solution for this. Again, it is going to be also a logical solution. There will be no any theory or formula required. Okay, it is a basic simple question. Think about it. We know what we know when we talk about the okay, when we talk about the focal length, it is all about the convex mirror. It is given as f. Simple words, it is given as f. Okay, in respective of positive and negative, whatever it is going to be a f only. You are saying A, Vandana, that is 3/4f. Let us see. Okay, so focal length of the convex mirror is given as f. Now, what we have done, we have taken that convex mirror and we have dipped into the water. Getting my point? Now, what we have to find it out over here, it is given as the refractive index. Refractive index of the water is given as 4/3. Fine, no problem. We have to find out the focal length of the mirror in the liquid. See, try to understand. We have to find out the focal length only. Getting my point? And focal length doesn't change because the mirror is not changing. The refractive index may change because now earlier the mirror was in air, now it is in water, so it may change. The refractive index of the mirror with respect to water may change, but when we talk about the focal length of that particular mirror, it will be same. It doesn't matter where you put it. Okay, so it will be F only. That is going to be C. That will be the answer. Okay, it doesn't change. It doesn't matter where you put. The focal length will be the focal length only. It is not going to change. Only one thing getting to change is that is the refractive index. Okay, but we are the question is asking about the focal length, so that is why the answer is going to be same only. Okay, chalo, that is what it is there, everyone. I hope it is understandable. Let us move to the next question, which is this. Again, it is also a very simple question. You don't have to bother much. Very simple question it is. What do you think, people? What will be the correct answer for this? Again, I am saying it is a very easy question. Very, very easy question. You don't have to think much. You know the result, just put this. You know the result already. What will be the correct answers for this? You already know the result. What will be the answer for this? Anyone? What will be the answer for this question? Again, it is a very simple question. You don't have to think much. It is to the point question only. Okay, see what is the answer is, we are talking about under which following condition. We are talking about the convex mirror, everyone. Okay, so if you know anything about the convex mirror, we know in convex mirror it is making only one kind of image, that is virtual and erect every single time. Virtual, erect and diminished also. Virtual, erect and diminished every single time. It is not a concave mirror, it is a convex mirror. Getting my point? It is a convex mirror. It doesn't matter where you put the object, it will be always create virtual, erect and diminished image. What is it asking? It is asking the of the focal length f, produce an image that is erect, diminished and virtual of the real object. Okay, so we have to find out what is the difference. So it doesn't matter where you put the object. It may be in infinity, it may be beyond the center of curvature, it may be in the center of curvature, between focal length and the center of curvature, between the pole and the center of pole and the focus, wherever it is required, wherever you put the object, it will be always and always giving you only one value, only one thing, that it is going to be virtual, erect and diminished. Virtual, erect and diminished. The same thing will be made. The same thing will be made every single time. This is in what? This is in properties of this. Okay, so that is why the answer will be D. That is always. It doesn't matter where you put the object. It will be making always virtual, erect and diminished image. Always. I hope it is clear to all people, right? Very simple, logical. You just need the if you have remembered that the properties of the convex mirror, then it will be the answer. The image formation of the convex mirror, this is going to be the correct answers for this. Fine. Chalo. If it is so, now let us move to our next question, which is this. This is good question. This is a very good question. I request you all to please look into this. This is a very, very, very good question. Okay, I'll allow you to 3 minutes for this. Okay, why not? I'll allow you 3 minutes for this. Please let me know your answers for this. Yes, come on, people. It is a very easy question. Very, very, very easy question. Chalo. So let me draw the figure so that I can explain you what basically it is going to happen. Fine. Chalo. Let us solve this thing. As you can see, everyone, the question is a ray of a light is incident normally on one side of the faces of the prism of apex. Apex means this angle. Apex means this angle. This angle is given as 30 degree. Fine, no problem. Okay. So angle of prism, apex angle means angle of prism is given to you. That is going to be 30 degree. And the refractive index of this particular mirror, refractive index of this particular prism is given as √2. Fine, no problem at all. What it is there? The angle of deviation we have to find. What we have to find? We have to find angle of deviation, people. We have to find angle of deviation. Now, how to solve this thing? Okay, so I'll teach you the shortcut also. I'll teach you the shortcut means if you are good in maths, it will be very much, it is one line answer. Okay, if you are not able to think about like this way, okay, you can use a basic approach that how to solve this thing. So let me teach you the basic approach first, that what we are going to do, how we are going to do, and then I'll teach you the shortcut also. Okay, so we have to find out the deviation, everyone. So we know the formula of deviation. Deviation is equals to angle of incidence plus angle of emergence minus the angle of prism, that is 30 degree. That is all it is given. Fine. Now we have to talk about the incident angle, emergent angle, and then we have to talk about the prism angle that is given, that is 30 degree. Fine. Now it has been already done. It is already been given that key. This is the incident ray and it is normal to one of the faces. If it is normal to one of the faces, that means it is overlapping with the what? That is the normal that we always draw na, to find out the angle between. So what is the incident angle, what is the refractive angle? Okay, so we are measuring from the normal only, so it is overlapping over the normals. Fine. If it is so the angle between at this particular point, at this particular face, everyone, as this face, this is an incident ray. Okay, this is an incident ray. So the angle of incident at this particular point will became 0. Why it will be becoming 0 degree? Because it is overlapping with the normal, and we always make the angle from the normal, so that is why it is completely 0. Fine. If it is completely 0, our intention is to find out the value of refraction over here. Okay, what will be the refraction value that we have to find. Now by looking into this only, you can say, sir, it is going to be 0 again. Okay, but still, since we are going with a very basic analytical approach, we'll solve it. Okay, so first we have found out that the incident angle will be equals to 0. Let us move forward with many more. Okay, so solution, everyone, as we know from the Snell's law, people know from the Snell's law. Okay, Snell's law. For this, okay, for this space we are talking about, for this particular point we are talking about. Okay, we say from Snell's law, we know that what we are talking about, that the refractive index of point 1. What is the point 1? This, let us suppose this is point. This is the first point. This side air, that is the first. Then the prism. It is sine of incident I will be equals to N2, that is refractive index of the prism, everyone, that is sine R, everyone, that has been there. We have to find out the sine R only. Fine. Chalo. So N, refractive index of 1, that we are talking about for the incident, it is air, so we are taking 1 for this, and sine I. So sine I is making, we always measure the angle from the normal, so from the normal it has been making, that is 0 degree, everyone. Okay, 0 degree. What is the value of N2? N2 is refractive index of prism, that is root 2 sine R, everyone. Okay, now, so sine 0 degree, it will be 0, will be equals to root 2 sine R. Getting my point? If it is so, we are getting that the sine, we are getting that R will be also equals to 0 degree. You can solve it down. R will be also equals to 0 degree. If this is I and this is going to be the R, so R is also going to be 0 degree itself. Angle of R is going to be 0 degree. Simple words, fine. But there is an issue. What is the issue? This much it is okay, but when the ray of light is touching, it is striking on the second phase. This second phase, every single thing change. We cannot say it is going to be 90 degree, it is also going to be 0. We have to find out the angle for this. Okay, so let us talk about this particular point. Okay, let us talk about this particular point. As you can see from the figure only, as you can see from the figure, that let us say this is going to be, if it is refractive 1, okay, let us say it is going to be refractive 2. We have to find out the refractive 2 with respect to the, and we have to find out the angle of emergent. Fine, no problem. Let us solve. We are talking about this point, everyone. Okay, we are going to find out the R2. Now, if you think very basically, if we are talking about this ray which is coming from this point now and it is going to this point, we can say this ray, which is a refractive ray, is going to be incident at this second phase. Yes. So in this particular case, from the Snell's law only, we can write that the N2, why N2? Because we are talking about this ray is coming from the prism, so that is why it is N2. N2 of sine of I dash. Why we are talking about I dash? Let us say R2 equals to I dash, which will be the incident of this particular phase. it will be incident angle of this particular face, है ना? R2 becomes this. So let us say R2 will be becoming I dash. Similarly, let us say the E becomes R dash. Okay, because we know sin I equals to sin R, so we'll just converting that thing only. Moving next, N1. Why we are talking about N1? Because it is going to be air again. N1 sin R dash. If you talk about this, N2 will be equals to R2 and sin I will be given as, what is the value of this? What is the value of this? That is a very good question. What is the value of this? Okay, so the value of sin incident I will be equals to 30 degree. Will be equals to 30 degree. How it is coming, I'll let you know, do not worry, that is the shortcut only. Okay, it is 30 degree, will be equals to N1, that is 1, and then we have to find out the sin R dash. Fine, so this is going to be root 2, sin 30 is equals to half, will be equals to sin R dash, everyone. If you solve this thing, you will be getting 1 by root 2 will be equals to sin R. So R dash will be coming out to be sin 1 by root 2. It is coming out to be how much? It is coming out to be 45 degree. Okay, that means angle of emergence is coming out to be 45 degree. Right? How 30 degree is there? I'll teach you. Do not worry. Okay. If R dash, that is the angle of emergence, is 45 degree, R is given as 0 degree, I is also given as 0 degree, basically. Okay, so from this particular formula, we can say angle of deviation, we can say the angle of deviation will be equals to angle I plus angle E minus angle of prism. Angle I became 0 degree, angle of emergence, it is 45 degree, minus angle of prism, that is 30 degree. It is coming out, the deviation is coming out to be 15 degree, people. The deviation is coming out to be 15 degree. So that is the long approach. If you do not know the shortcut, you can go with this. Okay, now let me teach you how to solve this thing in a one line, in a basic one line, how we are going to teach it. Okay, how we are going to solve it. So for this, your geometry should be a little bit good. Okay, then only let me teach you this. So as we know, people, there is a prism like this. There is a prism, and there is a ray of light which is coming and which is which is normal, or you can say perpendicular to the one face like this, which is perpendicular to the one of the faces. Fine. In that particular case, it is okay. Very good. Let us move forward. After this, just now we have seen it is overlapping the first incident. When we talk about the first phase, it is overlapping with the normal, as we can say. Okay, and when we talk about the second one, it will be like this. Second one will be like this. Okay, so it will be going to bend. 100% is going to be bent like this way. Fine. What is our approaches? We know what we are knowing over here. We know few things, that this is going to be 30 degree. If this is going to be 30 degree, we can understand that this angle is going to be 90 degree. Fine. Now let me name it. Let us say it is B. This point is B. This is A, and this is C. Let us see. You can see ABC as a right angle triangle. If it is 30, it is 90. So this is going to be 30 plus 90, that is 120. And this angle will be going to be 60 degree. This angle is going to be 60 degree. Simple words. If it is 60 and this total is 90, everyone see, this total is 90, then this particular angle will become 30 degree. This 30 degree, as you can see that I have wrote over here, this R2 becomes 30 degree. See how the 30 degree has came, that is the reason. This is 30, this is 90, this is going to be 60, 30 plus 90, 120 minus 180 minus 120, this is 60. This whole thing is 90, this is 30. If this is 30, everyone, again one thing I am saying, try to understand. This is going to be, if this is 30, this is this. So this is going to be, fine, this is 30, this is going to be, as you can say, this is going to be 90 degree, everyone. This is going to be 90 degree. Simple words, this is going to be 90 degree. if this is going to be 90 degree, we have to solve one thing more. Like how we are going to solve it. See, this is going to be 60, and then we are having 90 over here, 60 and 90. That is what it is there. As you can see over there, that is 60 and 30. At 60 and 30, which angle we have to find out over here? We have to find out this angle. This is the angle of deviation. Let me rub this thing. Sorry. We have to find out this. What is this? This is the angle of deviation, and this is going to be this pink color is going to be 90 degree. This angle is going to be 90 degree. That is what it is there. Right. This is what it is there. So we have to solve to find out the answer for this. Okay, we have to solve to find out the answer for this, and how we are going to solve this thing. How we are going to solve this thing? As we can know, this is going to be 90 degree. Okay, this is 60, this is 30, 60, 30, that is going to be 90, 90 and 90. It is going to be the angle bisector. Okay, so that is going to be, the theta is, this thing is going to be find out to be 45 by this. Formally, if it is 45, then you can move forward and you can find out like this, that the deviation will be, sorry, no, my bad. I'm extremely sorry, people. Okay, we have to find out the angle of emergence. My bad, I'm extremely sorry. Okay, this is the angle of emergence. It is going to be 45. Okay, so we know that this deviation will be angle I plus angle E minus angle of prism. Angle I, that is going to be 0. Obviously, it is 0. Okay, angle E is coming out to be 45 and minus angle A, that is 30 degree. So as you can see, it is going to be for 15, everyone. It is going to be 15 degrees. So deviation come again to be 15. One line, if you know the geometry, that's it. One line, if you know the geometry, it can be done. Okay, that is what it is there. I hope it is clear to all people and you have understood this much. Okay, that is what it is there. Fine. I hope it is clear to all. Or if you see, when we talk about this 45 degree, we can find out by the equation also. Put this equation over here. Put this where we go. This equation over this point. Because we have found out the 30 degree. So we can say that is going to be N2. Then we are going to be sine of incident I will be equals to N1. That is sine R. Sine R. Just put the values. N2 equals to root 2. This is going to be sine 30 because we have found out it is 30. Degree will be equals to 1 multiplication of sine R. R dash. So it is coming out to be that the R dash will be coming out to be 45 degree, which is going to be the angle of emergence, which is over there. Just put it. Okay. That's what it is there. Fine. This is 15. That is going to be the answer. I hope it is clear to all people. Let us move forward. So either you can go with this approach or just find out this 30 degree angle and you can write this equation and you can find out the answer. Simple. Chalo. Moving to the next. Please let me know the answer for this. Again, it is a very simple question. You don't have to think much. Okay, whatever that you have learned basic, let go with this. I request you all to please let me know the answers for this. Again, it is a very easy question. Yes. What do you think? No problem. Let me help you out with this. I see. This is very simple. It is just a confusion thing. Velocity of a light is given for in a glass whose refractive index with the respect to the air is given as 1.5 and the speed is given as this much. Fine, no problem. In a certain liquid, the velocity of the light is found out to be 2.5 into 10 to the power 8 meter per second. The refractive index of the liquid with respect to the air. With respect to the air, it is talking about the absolute refractive index, everyone. So what we know about the absolute refractive index? Solution for this, people. As we know, for the absolute refractive index, okay, which is going to be n absolute. How to solve this thing? We know that is the speed of light in air / vacuum divided by speed of light in medium. That is given. Medium, that is given. So absolute refractive index can be, so speed of light in air and vacuum, that is c only, which is equals to c divided by this, that is velocity of the light in the medium. And what is the medium? That is liquid. Okay, so refractive index we have to find, absolute refractive index we have to find. The value of c is 3 into 10 to the power 8 divided by the velocity of the light in the medium, that is given as 2.5 into 10 to the power 8. As you can see from the simple maths, people, okay, this 10 to the power 8 is going up. It is going to be 8 minus 8. It is going to be gone. Okay, so we can write it down over here that absolute refractive index can be 3 divided by 2.5. Solving, it is going to be 30 divided by 25. Solve it, it is going to be 5, it is going to be 6. Moving forward, 6 by 5, it is coming out to be 60, 1.2. That is going to be your answer. 1.2, people. That is C. Simple equation, simple question. You don't have to bother that much. It is a very simple thing. It is just for given the confusion only. Okay, at the end, it is asking about the velocity of the light with respect to the air only. Fine. So let us move to the next question, please. Again, it is also a very good question. Okay, it is also a very good question. 3 minutes, people. Come on, let me know the answers. For solving this question, you have to know one concept in this. That's it. Except the formula, you should know only one thing. If you know only one thing in this particular case, okay, it has been solved. Believe me. Okay, it is going to be solved. Only one thing that you know, accept the formula. You should know. That's it. Yes. What do you think how to solve this question? Anyone with the solution, please? What do you think? It's pretty simple question, people. Only one concept you require to solve this thing, accept the formula, and every single thing will be done. Anyone with the answer? No? No problem. Let us solve this particular question, everyone. Time up. Solution for this. It is a pretty straightforward question, but there is one concept that is required. See, a wire of a resistance R is stretched to 4 times its initial length. What will be the new resistance? Fine. So let us say like this way. We know one thing. We know the formula for the R. R is equals to the resistivity, which is totally into the material, the length of the conductor divided by the area of cross section. Fine. Now, in this particular formula, what are the values that we are having? We are having the length is going to be stretched 4 times. Okay, it is going to be changed 4 times. Fine, no problem. And from the initial length, fine, no problem. Now, what will be the new resistance? Now the thing is, in this type of question, there is one concept that is required. What is that concept is? Please do note it down. Until and unless it has been said, please do remember in this type of question, we have to maintain volume which should be constant. The volume do not vary. Okay, if your length is 4 times, 5 times, you make it half, it doesn't matter, but volume should be constant from the previous one to the new one. The volume should be constant. Okay, the volume is not going to vary. When we talk about the volume, over here, so the volume should be constant, so it will be equals to, when we talk about the volume, we will let you know. Okay, let us decide the name first. Suppose that earlier everyone, there was no changes, so it will be R1 will be equals to density 1, length 1 divided by area of cross section 1, when there was no any changes. Now when we talk about R2, people, now this is change that happens, so density 2, length 2 divided by area of cross section 2. Simple words. Okay, now as we can say that the volume is constant in that particular case, we can say that whatever the change that happened, it happens in the length 2, and whatever it is going to be happen, it is going to be happen in the second part, because it is being changed 4 times. So since the volume should be constant, so it means the area 1, the cross section 1 multiplication of the length 1 will be equals to area 2, cross sectional area 2 multiplication of L2. It should be equal because we have to maintain the volume, okay, which should be constant. In that particular case, we can write area 1 multiplication of length 1, which is there is no any change in this, area 2 multiplication of length 2. Now there will be change in length 2, so we have to find out the area 2 over here is A1 L1 divided by L2. What is happening in the L2? So A2 area 1 length 1, and when we talk about the L2, it is going to be 4 times of L1. It is going to be 4 times of the L1. So you can solve it from here. This L1 and this L1 is cancelled out. We are getting that the A2 will be equals to 1/4 of A1. So this is one of the things that you should remember. Okay, this is one of the things that you should remember, that A2 will be equals to A1/4. Fine. Now what we have to do is, as we have to just compare it. Okay, how we are going to compare? We are going to compare R1 by R2 will be equals to, what is R1? That is density 1, length 1 by area of cross section 1 divided by density 2, resistivity 2, length 2 divided by A2. If I have said this is density, this is because in grade 9 it is also represented density. It is resistivity is totally dependent on the material. Since in this particular question we can understand over here is that the densities are not, the resistivities are not going to be changed because it is the same material that we are using. So we can do one thing from here, that this one and this one is cancelled because the resistivities are same. Now moving next, we can say that the R1 by R2 will be equals to length 1 by area of cross section 1 divided by length of 2 divided by area of cross section 2. If you solve it further, R1 by R2 can be written as L1 by A1 A2 by L2. Solve it everyone. R1 by R2 can be written as, see, L1 is L1 only, that is simple L, there is no any changes, divided by area 1 because there was no any changes in the length or something like that, so that is what it is there. When we talk about the area 2, so we have found out the area 2 is equals to 4 times of area 1, 1/4 of area 1 divided by L2. L2 is what? That is 4 times of L1. Fine. In this particular case, what else we can write? That the R1 by R2 will be equals to L1 by A1 multiplication of, we can write it down that this way, that the A1 by 16 L1. Now from cross multiplication, people, we can do this and this is cancelled, this and this is cancelled. What is getting out? That the R1 by R2 is equals to 1/16. But we are interested in finding out the R2. In that particular case, R2 will be equals to 16 times of R1. That will be the answer, people. Okay, that will be the answer. What will be the answer? Sorry. This will be the answer. This will be your answer, people. This is going to your answer. That is R2 will be equals to 60 times of R1, which is this. Hey, I hope it is clear to you and you have understood this much. Okay, sure. Let us move forward. What about this? What about this, people? What do you think about this? See, it is a very straightforward question. Question says, given the simple electrical circuit at the right at the right, which is this. Okay, if the current in all the three resistors are equal, which of the following statement must be true? Now, as you can see in the figure, we know few things that what we are able to understand. This is going to be positive, this is going to be negative. The current is moving from here, that is going to be I, and it is getting inside the current I only. When it is reaching to this particular point, the current is going to be divided. Let us say it is going to be I1. At this particular point, it is going to be I2. It is moving out to be I2 from here, and it is moving out to be I1 from here. At this point only, at this point, we are getting I1 plus I2, which is equals to I only. Fine. Now, by looking into this figure, we can understand that this is going to be parallel only. But we have learned, what we have learned, for parallel combination, we have learned that the current will be different for each resistor. This is what we have learned. And potential difference, or you can say the voltage will be same for each resistor. Fine. But still, by learning this also, we are getting one thing. What we are getting is, in this particular question, it has been said, no, since they are in parallel combination also, but still the value of I1 and I2, both are same. If this is going to happen, then there is only one reason. The reason is the resistance are same. Then only this is going to be happen. The resistance of Z, the resistance of X, the resistance of Y, all are going to be same. Then only this is going to be happen. Same resistance requires same amount of current. Okay, that is why it is going to happen. But since we have learned for the parallel combination, these are the points that we have to remember for the parallel combination. But still the question is saying that the current is passing through the resistors which are same. That only can happen when the resistors values are same. Okay, because same resistors value, the resistance value is same for each resistor, it will be acquiring same amount of current. That is why it will be A, everyone. X, Y, Z all are equal resistance. Moving to the next question, please let me know this value. Or before getting into this, there was one more electrical question. This. Solve this. This is one more electrical question. Please solve this. Solve this, people. Chalo, let me help you out with this. Take it. Very basic. See, this is positive. This is negative. The current will be going like this. Okay, let us say it is I. Over here also it is going to be I. Till this particular point, sorry, it is not going to be I1. It is going to be I only. At this particular point, the current is going to be break. Let us suppose that this current 0.1 is going to be I1. And this is going to be I2, let us say. Fine. Again, it will be coming to this particular point. It is moving, and at this point, we are getting I1 plus I2. Simple, which is equals to I only. And the I is getting inside it. Fine. Now, what we have to do is we have to find out a current of 0.1 ampere flows through the 25 resistor that is over there. Okay, represented by the circuit diagram. The current in the resistor 80 will be how much? What will be the current will be there in the resistor 80? What will be the current which is passing through the 80? Fine, no problem. We can find it out. It is very simple to find it out. So still, okay. Now, what will be happening is very simple. As you can see, it is 25, right? The current is passing through these resistors, and 20 and 60 are going to be in parallel, everyone. So if they are is going to be parallel, so we have to change this thing, and it is going to be one resistance over here, which is going to be series in 25 with going to be series with the 25. So what we can write over here is the solution for this. The solution for this, what we can write is, we can simply write ki see 25 and 20 and 60. 20 and 60, they are in parallel. Whatever the equivalent resistance they are here that is going to come, it is going to be series with the 25 only. Okay, so what I can write simple thing over here. Since we can write, what we can write is, see, 25 plus this thing, that is 60 multiplication of 20 divided by 20 plus 60. So if you try to solve this thing, 25 plus, it is going to be 11200 divided by 80, everyone. This and this is cancelled out. This is 4. This is going to be half, that is going to be 60. I believe it is going to become as 15, everyone. Okay. This is going to be come as 15. This and this is cancelled out. It is going to be 15. 15. So 25 plus 15. It is going to be 40 ohm. So 25 plus this entire resistance became 40. Fine. Now this 40 will be having 0.1 ampere of current. Fine, no problem. And we have to find out for this 20, everyone. Okay, that is I2. No problem. Okay, so we can say since these are all in series, the potential difference so we can say that the current is same, the potential difference is going to be vary for this. If it is so, all are in series now. So if it is so, we can write it down like this way, that the I1 and this R equivalent, that is 40 ohm, will be equals to I2, that is that we have to find multiplication of 20. So I1 is coming out to be I1 is given as 0.1. multiplication of 40 will be equals to I2 multiplication of 20. Okay, so what we are getting is, as you can see from here, this and this is cancelled, it is 2. It is going to be 20, everyone, ampere. Okay, the current is going to be 20 ampere. It is 210. Sorry, 0.1, it is 10 will be, no, I have made a math mistake, sorry. This is 1 by 10, multiplication of 2 will be equals to I. This is going to be 5, everyone. The value of I is coming out to be 0.2, sorry, my bad. It is coming out to be 0.2 ampere. So we have found out the value of I2 is going to be 0.2 ampere. Fine. Now, as you can see, if you resolve this entire thing, you will be getting only one thing, that is over here, that is I. So I1 plus I2 will be coming out to be I only. So in that particular case, I will be equals to I1 plus I2. So the value of I will be equals to 0.1 plus 0.2. The value of I is coming out to be 0.3 ampere. That will be your answer. Do we have? That is 0.3, everyone. Okay, I hope it is clear to all. Okay, sure. Now, if it is so, people, there is one more question. It is for you. Try to solve it. It is a very easy question. But there are certain values that has been not given over here. So let me write that values for you, so that it will be very much easy to you for the solving it. Okay, the values will be, if sine 50 degree will be equals to, I believe it is 0.5 something. No, 50 will be equals to 0.766, and sine 0.574 will be equals to 35 degree. These are the two values that is already given. I request you all to please solve this question. Okay, this is going to be your homework, people. That's it. Okay, solve it. And this is going to be the end of the session. Please do not forget to register for the score examination, and the examination is going to be on 28th September and 12 October, people. Like, comment and share and subscribe this particular channel. You can connect with us in a different social media platform, that Instagram's your YouTube channel, Telegram, then we have app, and the first Facebook also, people. Okay, so this is all for the day. Thank you everyone for joining. Bye everyone, take care, have a nice day. And I believe this is what, if you do this much, it is more than enough for your score examination. Thank you everyone for joining. Bye everyone, see you all. Thank you.